Today we're going to be looking at writing equivalent expressions or simplifying expressions with exponents. So we need to go back and recall some of our basic exponent rules. If you remember the power to a power rule that said any number to a power A, right, to another power B, then you're multiplying those powers. So this would be A times B, and you're keeping your the base of your exponent the same. So first we want to look at our numerator and denominator and ask ourselves, can we simplify anything? So in this case, we can simplify this power to a power. So in our numerator, then we would have 4, and it would be m to the 4th times 3, because this is a power to the power rule. So it would be m to the 4th times 3, which is 12. So this would be m to the 12th power over 5m to the 5th power. In our denominator, we can't simplify that, but we can simplify these two whole fractions. So we can split this fraction up into 4 over 5 times m to the 12th power over m to the 5th power. So here's our difference of powers rule, right? When we are dividing exponents, then we subtract the exponents. So this would be m, same base, to the 12 minus 5, which is 7. So this would be 4/5 times m to the 7th power. Okay? We could also just write that as 4m to the 7th power over 5. I'm sorry, no, we can't write that. We cannot write that. This would be our final answer. Those are not the same. Okay. Actually, no, we could write that. I'm sorry. We could write what I crossed out. Sorry, it's been a long day. All right, let's look at example number 2. So we have 6z. So here a z is our exponent, over 2 to the quantity z squared to the 5th power. So again, we have our power to the power rule in our denominator. So we want to start by simplifying that. So our numerator doesn't have anything that we can simplify. It's just 6z, right? No exponents. 2, power to the power rule says that we multiply our exponents. So this will be z to the 10th power. And again, we want to simplify our fractions. So we're going to have 6 over 2 times z over z to the 10th power. So whenever we have, and remember there's an invisible exponent of 1 whenever you just have a number or just a variable. So 6 divided by 2 is 3. Z to the 1st power over z to the 10th power is z to the 1 minus 10th power. So 1 minus 10 is negative 9, right? Remember that our negative exponents turn our fractions into its reciprocal. So instead of this being z to the negative 9th power, we can write this as 1 over z to the positive 9th power. So remember that, right? So if we do z to the positive 9th power times 3, that then will be the same as 3 over z to the 9th power. Okay, so negative exponents turn things into their reciprocal, turn fractions into their reciprocals, or just move something from a numerator to a denominator or denominator to a numerator. And let's take a look at this last example. We have 10d to the 9th power over 2d squared to all of that to the quantity cubed, or to the 3rd power. So I'm going to focus on our denominator. There's not much that we can do in our numerator. But in our denominator, it's important to notice that this time the 2 is inside the parentheses. The coefficient is inside the parentheses, whereas with this one, it was on the outside of the parentheses, and same thing with this one, this 4 in our numerator. So because it's in the outside of parentheses, that means that everything in the parentheses is getting cubed, right? So we kind of have to distribute the 3 to both of those terms, to the 2 and to the d squared. So our numerator is going to stay the same, 10d to the 9th power. In our denominator, we're going to have 2 cubed. Well, let me just show you the distribution. It's 2 to the 3rd power times d squared to the 3rd power. So we distributed that 3 to the 2, right? And distributed the 3, or the cube, to the d squared. So now we have in our numerator 10d to the 9th power over, well, 2 cubed is 8, right? And d squared cubed is, again, our power to a power rule, so that'll be d to the 6th power. 2 times 3 is 6. And then we have 10 over 8, I'm going to split this up, times d to the 9th over d to the 6th power. Well, 10 over 8 I can simplify. The greatest common factor between 10 and 8 is 2, right? So if I divide both of these by 2, I get 5/4 times, and here we have a division problem with exponents, so we're going to subtract our exponents. 9 minus 6 is 3. So this will be d cubed, or d to the 3rd power. And again, I can just rewrite that whole expression as 5d cubed over 4. So that would be our final answer here in our box.